In NSO, we have two different types of models. The bottom one here is the device model. The device models are specified by the NEDs. So if you have a Cisco iOS NED, you will have a device modeled for the iOS operating system. If you have a Cisco XR device, you're going to have a device model mapping to the XR or any third-party NED. Then you have the service models, which are typically used by a northbound user or system to input the parameters that make up the service. So this could be any kind of service, a layer 2 VPN, a layer 3 VPN, or a layer 4 through 7 application. The job of the service is then to map the service model parameters to device model parameters. So for example, in the service we're going to work with here, we have a service model to the left in Yang. So this is the access service we're going to use. And the arrows show how these map into a Cisco iOS model to the right. So for example, the VLAN is used as a number of places, so we will map the VLAN value to the VLAN value on these different places in the iOS configuration. Same thing with the customer name and the access and the trunk interfaces. So with that, let's get started. So we're going to use this as a basis for building our service later on. NSO supports a number of northbound APIs that are automatically rendered from the Yang models loaded into NSO. Here we're going to focus on the Python northbound API. The Python northbound API is built on top of the MAPI API. MAPI stands for Management Agent API and is in its core written in C. An NSO transaction is a database transaction that is opened at the start. The northbound system then makes changes to the database and commits these atomically. Python also provides a number of high-level APIs. One of those is the Magic API. The Magic API simplifies interaction with NSO in Python by providing standard Python object dot notation, so you can actually navigate down the configuration tree using simple dot rotation. It also provides context handlers to automatically close sockets, sessions, and transactions, for example, if an exception is thrown. This prevents leakage of transactions and sockets. It also abstracts away the need to know the exact data type of the leafs. That is all handled by the Magic packet. To interact with the Magic API, we're going to use the IPython, the interactive Python shell from the Jupyter project. So in here, I'll just paste in a couple of lines like this. So the first two lines are just to import the NCS packages we're going to use. The other one, the third line, opens up a MAPI session. And the fourth one opens up a user session with username admin and just a name for the context. Then we are starting a writable transaction, and the last thing we do is getting an NCS root object. So in this state, I have IPython in a very similar way to the CLI, to the NSO CLI. So what I can do now is I will take my root object and I can hit tab to tab complete. So for example, I can get the device, devices, like this. So let's say I want to take the iOS 0 device I have. I can do this, iOS 0 equals. So now I can do pretty much the same thing I can do in the CLI from here. For example, I can do iOS 0 sync from. And when the device is synced from, I can now start to go down into the config the same way I do in the normal NCS CLI. So I can hit tab complete here. I know it's an iOS device. For example, look at the gigabit Ethernet. So I see that this is a list. So now I can, for example, iterate over that list and kind of call for each gigabit Ethernet in here. I'm just going to print the name of the interfaces. And if I wanted to do some change, for example, I could, instead of printing the name, I could, for each of these guys, say I want to set the MTU to 1400, like this. And with that in place, I can now I have a transaction object. I do an apply, like this. Like this. Now if I go into the CLI, I can actually show running devices, device, I can see that I've updated the MTU to 1400 on all of these. Say I want to make another change. Since I have applied the transaction, I'm going to have to recreate my transaction. So what I'll do is, I'll start another write transaction. I get my root object again. And then I'm going to reapply this, like that. So I can do this step is, I can do in for loop here. I can actually remove the MTU I just created, like this. And again, I'll do a tapply, and back into the CLI. I can now see that I've removed the MTU from all my devices. So this is a quick introduction how you can interact with NSO using the Python APIs. So we're going to continue with creating a Python service that actually implements a service like this. In a previous video, I did this service using just templates, and one of the input parameters to that service was the actual VLAN. So in this case, it's 607. In the Python service now, we are going to skip having VLAN as an input parameter and rather allocate that from an ID pool. Please note that I've also added the access package to my project metadata file. And with that, and after adding that, I'm going to have to run the NCS project update -y. Like this. I can now make this package. What I've also done is I've copied the Yang file from the previous video into this. So let's just quickly look at that. See here I have my access service. It takes a customer name as input. We've got to point out the device and specify the access interface and the trunk interface. What we will not do now is I will not specify the VLAN here. So I will actually remove this from my Yang file. So we're going to grab the VLAN from one of the resource pools instead. And again, let's look at the template file. Like this. So the first thing that we have to do to convert this from a pure template service to a Python service is to remove the service point in here. If we had kept the service point in the template, we would have applied the template without running a new Python code. So I'll just simply delete that, like this. Since we're not going to use the VLAN from the Yang file, I'm going to switch this to a variable that we're going to send from Python later on. So just bear with me. Like that. So $1 and a name will be a variable that we'll set from either Python or a Java service later on. So first, let's take a look at this service point that is defining the Yang model. So I'm going to switch over to the main.py file. So this is actually generated by NCS make package. And the first thing I do is I register a service with the same service point thing, namely access service. And what I register is a service callback. So every time my service is created or modified, I will receive a call into this function cbcreate. In the first few lines here, I'm actually allocating a VLAN from a pool called VLANs. And when I have that VLAN, I can actually set that variable, VLAN, in the access template XML. So let's just quickly switch over to that. So that corresponds to setting this value, $VLAN. So that is pretty much simply what this simple Python service does, is it allocates a VLAN, it adds the VLAN value as a variable. It applies a template called access template. And that is pretty much all there is to it. So if I go here, I do a packages reload. I can now create an access service. Call it Cisco Device iOS 1 Access Interface Gigabit Ethernet 0/1. And now if I commit this, I can see what actually happened. I see that it modified these and it actually allocated a VLAN for me from a pool I had. So it now sets the VLAN to 1001, both in the VLAN list and on the switchboard. One thing that might come in handy is to look at the logs generated by your Python script. So again, if I switch back here, you see that I have a number of log files. And what can be helpful is to actually do something like this. So I can do self-log info VLAN equals. I can log the VLAN I receive. So after adding that, I will go out to the config mode, how to do packages reload to reload the Python code. Now if I do access Cisco redeploy, I will rerun the code. And having done that, I can now go into the logs directory and do a tail of logs NCS Python VM access log. You can here see that I have a Python log with the same name as my package. And here you can see the logs coming out. VLAN 1001, for example. So logging is all good to report some kind of information, but it's good if an operator, for example, can look at the service and see what VLAN was actually allocated to it. So what I've done here is I've added a VLAN leaf to my Yang model, to the service model. But please note that this is not configuration data. It's config false, meaning that it's operational data, and with these tags I'm saying that it should be persisted into the CDB, meaning it will be stored there. So what my service will do is it will report back to the operator what VLAN was allocated. So first thing we do is I'm going to compile this. And the next thing I'm going to do is I'm going to have the Python code report back to VLAN. And we can simply do that by going into main.py here. And just after the log, we can actually write this back. So after adding that, the VLAN tag will now be in my service. And I can simply do service VLAN equals VLAN. So this is the VLAN I allocated, and this is how I report it back. So if we go into CLI now, I'll do packages reload. And what I'm going to do is I'm going to redeploy the service to rerun the code. And now if I do a show access, you can actually see here that the service is reporting back the VLAN that was allocated.